Welcome everyone, and today we'll be doing complete revision of chapter squares and square roots. I have divided this chapter into 10 subtopics and we'll be covering 5 topics in part 1 and remaining 5 topics in part 2. So what all we are covering in part 1: properties, Pythagorean triplet, what should be multiplied, what should be added, and prime factorization. So let's get started. First is properties. No square number ends with 2, 3, 7 and 8. If any number is ending with 2, 3, 7, 8, that number is straight away not a square number. Property number 2 says every square number ends with even number of zeros. So there will always be even number of zeros, 2, 4, 6 or 8. Property number 3 says there are 2n numbers of non-perfect square number between the squares of two consecutive natural numbers, the numbers which are coming one after the other. So there will be 2n numbers, non-perfect numbers between the square of those two perfect square numbers. So property number 4 says the sum of first n odd natural number, there shouldn't be any gap. So the sum of first n odd natural number is n square. You need to count how many odd natural numbers are there. Just square it. That will be the sum without actually calculating the sum. And fifth property says square of number ending with 5. This is only for numbers which are ending with 5 is equal to number and n plus 1. So we'll be doing all the questions based on these properties one by one. Let's see. So first topic is based on first two properties where no square number can end with 2, 3, 7 or 8 and every square number ends with even number of zeros. So find out whether the following numbers are perfect square or not. Since this number is ending with 3, so no, it is not a perfect square. Again, this number is ending with 8, so no, straight away using properties. This number is ending with 7, so no. Next number is ending with 9, so may or may not be. This you need to check. Next, there is a single zero, and as per property, square number always end with even number of zeros. We have only one zero, so straight away no. This number has two zeros which is even, so it may or may not be. So using these two properties, just by looking at the number, we can say whether this is a perfect square or not if they are ending with 2, 3, 8 or 7 or odd number of zeros. Moving to next, our property number 3 says there are 2n non-perfect square number between the squares of two consecutive natural number. Let's see with the help of example. How many natural numbers lie between the square of the following? So 1 is 19. You need to find out 19 square, 20 square and then the numbers between them. So if we'll do with actual calculation, you need to find the square of 19, then find the square of 20 and then find out, you need to count how many numbers are lying between. But using the property, it makes our task easier. So we can say this is our n, this is n plus 1. So directly multiply n with 2, you will get the number of non-perfect square numbers lying between two perfect consecutive square numbers. So do this B part by yourself. Now moving to our property number 4 and 5. Property number 4 says the sum of first n odd natural number is n square. So you just need to count the numbers mentioned in the questions how many numbers are there here, starting from 1 till 19. So in total we have 19 numbers. So using properties, find out the square of number, total number, and that will be your answer. So without actually calculating the sum, you can find out the sum using this property. Now second question, you can do it by yourself as a practice. Moving to property number 5, find out the square of a number which is ending with 5. So here is a number 95 which is ending with 5. So a number which is ending with 5, first find out the square of last number, that is 5 is 25, and then whatever be the remaining digit, add 1 to it, it will become 10, and then find out the product. 9 into 10 is 90, add 25 at the end. So the result of 95 square is 9025. Now try the next for 65 by yourself using the same steps. Now moving to our second concept, that is Pythagorean triplet. All you need to remember, there are 3 numbers in Pythagorean triplet as the name suggests, triplet. So first is 2m, which is the smallest. Then we have m square minus 1, m square plus 1, where m square plus 1 is the largest one. So how we will solve these questions? Find the Pythagorean triplet whose one member is 12. So you can pick 2m is equal to 12. If question says the smallest member is 12, equate it with 2m. Even if it says one of the member is 12, equate with 2m, because here calculation becomes easier. Because in other two members there is a exponent, that is 2. So without exponent, solution is much easier than with the exponents. So what is m here? M is equal to 12 divided by 2, which will give you 6. Now our m is 6. We can find out the other member using the formula m square minus 6. 6 square minus 1, that is 36 minus 1, 35. And other one is m square plus 1. It will give you 36 plus 1, that is 37. So our 3 members are 12, 35 and 37. Now you can check from here, 12 is the smallest one and m square plus 1, which is 37, is the largest one. So you can try next question where one of the member is 14 by yourself using the same concept. Moving to next subtopic, that is prime factorization. Find out square root using prime factorization of 298116. I have intentionally taken a big number so I can show you the procedure properly. Pick the smallest prime number with which this number is divisible completely. So since it is an even number, try with 2. 2, 1, 2, 4, 9, 0, 5, 8. Again it is an even number, divided by 2. 2, 7, 14, 2, 4, 8, carry over 1, 5, 10, 2, 2, 4, carry over 1, 9. Now this is not an even number, so try the next prime number, which is 3. 3, 2, 6, carry over 1, 3, 4, 12, carry over 2, 8, 24, carry over 1, 4, 3. Again it is divisible by 3, 8, 3, 24, 3, 2, 6, carry over 2, 8, 3, 24, 1. Now this number 8281 is not divisible by 3. Reason being, if you add the digit which is not divisible by 3. 8 plus 2, 10. 10 plus 8, 18. 18 plus 1, 19. And 19 is not divisible by 3. So the whole number is not divisible by 3. Divisibility rule of 3. So we'll move to next prime number, that is 5. Since the number is not ending with 5 or 0, so it is not divisible by 5 either. Moving to 7. Yes, it is divisible by 7. 7, 1, 1, 8, 3. Again, it is divisible by 7. 7, 1, 6, 9. Now, 169 is a perfect square of 13. So, 13, 13, 1. Make pairs to, as we are dealing with square root. So, we'll make pairs 7, 13. Now, multiply these numbers and that will be the square root of 298116, which is further equal to 546. Moving to next word problem, which is based on prime factorization only. The product of two number is 1575 and their quotient is 9 by 7. Find the numbers. So let the number be x. If I'll say product of two number 1 into number 2 is equal to product. So if one of my number is x and let the other number be 2 only, product is given 1975. So you can convert your second number into first number form. So my one number is x, other number is 1575 divided by x. Now second information says their quotient is 9 by 7, which means if you divide number 1 by number 2, the result is 9 by 7. Replace it. My number 1 is x divided by number 2 is 1575x is equal to 9 by 7. Now change this division into multiplication. Reciprocal will take place. X upon 1575 is equal to 9 by 7, which is further equal to x square upon 1575 is equal to 9 by 7. Now send this 1575 to other side. It will be x square is equal to 9 by 7 into 1575. First check whether they are divisible or not. So 7, 1, 7, 2, 14, carry over 1, 7, 2, 14. Carry over 3, 7, 5, 35. X square is equal to 9 into 2, 2, 5. Now this 2 will go to the other side, square will go to the other side, it will become square root. Now if you check individually, these numbers are perfect square. 9 is a perfect square of 3 and 2 to 5 is a perfect square of 15. So our final result is 15 into 3 is 45. If one of the number is 45, other number will be 1575 divided by 45. Both are divisible and that will give you 35. So my two numbers are 45 and 35. So this is question based on same concept. Try by yourself. Our next subtopic is what should be multiplied. So whenever question says what should be multiplied or what should be divided, use prime factorization method only. So find the smallest number by which 2, 3, 5 to make it a perfect square. So we will use prime factorization. is it a perfect square or not? Since this number is even number, so we will start with 2, 2, 1, 2, 1, 2, 7, 14, 2, 6, 12. Again it is divisible by 2, 2, 5, 10, carry over 1, 2, 8, 16, 16, 2, 2, 2, 4, carry over 1, 2, 9, 18, 4. Again divisible by 2, 2, 1, 2, 4, 8, carry over 1, 7. It is divisible by 7. 7, 2, 14, 7, 1, 7. Then again it is divisible by 7. 7, 3, 21, 3, 1. Make pairs. 2. Again we have pair. But 3 is alone, which means 3 is extra. So what we will do? We will multiply 2352 by 3. So this is the smallest number by which if you multiply 2352 with 3, you will get a perfect square number. So try next question by yourself. Moving to next, what should be divided? So as I said earlier, whenever question says multiply or divide, use prime factorization method 9408, starting with 2 as it is an even number, 2, 4, 8, 2, 7, 14, 0, 4. Even number 2, 2, 4, 2, 3, 6, 2, 5, 10, 2, 2. 2, 2, 1, 2, 2, 1, 2, 2, 7, 14, carry 1, 2, 6, 12. 2, 5, 10, carry over 1, 2, 8, 16, 16. Then again 2, 2. Now 2, 9, 4 divisible by 2, 2, 1, 4, 7 divisible by 3, 3, 4, 12, 9, 7, 7, 7, 1. Make pairs. 2 in pair, 2 in pair, 2 in pair, 7 in pair. This is extra. So we need to divide 9408 by 3. So this is my smallest number. Now try this next question by yourself based on same concept, division. Moving to next question. Find the smallest number which is divisible by each number. So smallest we can say least also. So these are the keywords used for LCM. So first we will find out the LCM of 8, 9, 10. 2, 4, 8, 9 is not divisible, 5. Now again 2, 9, 5, 2, 1, 9, 5. Then we'll move to 3, 1, 3, 5, 3, 1, 1, 5 and 5. 1, 1, 1. Now check which numbers are in pair. Concept is same, finding pair. 2 is in pair, 3 is in pair. Only this 2 and this 5 is not in pair. So if we provide one more 2 and 5, then all the numbers will be in pair. So first find out what is the LCM. 2 into 2 into 2 into 3 into 3 into 5. So 5 to 10, 10 to 20, 20 to 40, 40 into 9, 9 for 36. So 360 is our LCM, which is definitely not a perfect square. Reason being 2 and 5 is not in pair. So if we provide 1, 2 and 1, 5 in this category, our LCM will become a perfect square. 360 into 10 will become 3600, and this is a perfect square. We have even number of zeros and 36 is a perfect square of 6. Hence, which is the smallest number divisible by each of the following number? 3600 is the smallest number which is divisible by each one of the number 8, 9 and 10. So here comes to the end of our part 1, where all 5 topics are discussed. Remaining 5 topics will be covering in part 2. Thank you.
Follow Mathematics Boosters for such videos. Thank you.